The plan for this lesson is to discuss dimensionality reduction. We will go over the definition of the curse of dimensionality and in high level discuss dimensionality reduction techniques including feature selection, feature generation, and feature extraction. At this point, we understand how the data is very high dimensional, like millions and billions of features. And for high dimensional data, computing the distances and density becomes complicated. So as a result, all of the tools we use for analysis, such as classification and clustering, become challenging computationally. And the meaning of the results also becomes hard to interpret. In dimensionality reduction, the goal is to reduce the number of features and the number of random variables, so we can only focus on those subsets of features that contribute the most to the problem we are trying to solve. The advantages of performing dimensionality reduction are overcoming the curse of dimensionality side effects, remove irrelevant features, reduce noise, also reducing processing time and storage, allowing creating better visualizations. There are two approaches for dimensionality reduction. Supervised and nonlinear techniques require intervention from the user or the data has labels or guidance. And under supervised and nonlinear approach, we discuss two subcategories. For feature selection, we try to condense the total number of features by selecting a subset that is representative of the overall features. And for feature generation, we leverage all the domain information and existing features to create new features that captures most of the information. For the unsupervised case, there are no labels or guidance, so we use linear algebra methods to transform high dimensional data, fewer dimensions that still capture most of the variation in the data, like what we do in principal component analysis or PCA. In attribute subset selection, the goal is to identify the attributes that are most relevant to the problem. And because this is a supervised method, identifying and removing redundant attributes and irrelevant attributes is straightforward. In this graph, we show how a number of features are ranked and sorted so the attribute selection process can be done in effective way. Attribute selection can be approached as a heuristic search problem because there are d attributes and a total of t to the power d possible attribute combinations, and we are trying to find the smallest representative subset. A great place to start is running independence or correlation tests. For correlated attributes, we only need to keep one. For independent attributes, we might need to keep both of them. Then we can go over this iterative stepwise process where we select the best single attribute, then the second best attribute, and so on. Or we can start by elimination, eliminating the worst attribute, then the second worst attribute, and so on. Overall, the key advantage of this approach, it maintains a great degree of interpretability. Feature generation, also known as attribute creation, is a process to create new features from existing data to capture important information effectively. Some of the methods are attribute extraction, which involves creating new features based on domain knowledge. Also, data reduction can be thought of as a feature generation method, and attribute construction, as we combine existing features or doing data discretization. In summary, we discussed dimensionality reduction and dimensionality reduction techniques, including feature selection, feature generation, and feature extraction.